Hello everyone, this is 6.1 rational expressions. So the first thing we're going to talk about is what is a rational expression. Okay, so this chapter and section is really just a building up of what we've been doing before. So factoring, multiplying, polynomials. So we really need to understand what is a rational function. That's simply a function where the denominator and numerator are both polynomials, okay? So if we have some division with polynomials, we have p of x over q of x. So q of x cannot equal 0, okay? Because if we divide by 0, then that means it is undefined. So we can't have that, okay? With that in mind, let's talk about the domains of different functions here. Okay, so the first example, we have f of x equals 3 over 7x minus 14. We already talked about the denominator cannot be equal to 0. Whoops, that's a little big. So the denominator cannot be equal to 0. So we need to just find the domain of this by setting the denominator equal to 0, and that's the value it cannot equal. So it's going to be all reals except, okay, and we're going to find out what values of x make this go to 0. Okay, something's wrong with my Apple Pencil. There we go. Okay, so set this equal to 0. So then we add 14 to both sides. We get 7x equals 14. Divided by 7, we get x equals 2. But it's not equal to 2. We need everything except 2. So we put x cannot be equal to 2. Okay, next up, we have a little bit tougher example, but the same principle applies. We cannot have x squared minus 4x plus 3 cannot equal 0. So that's what we're going to do. From now on, this is kind of like the easier way to show it. You just put not equals 2, okay? And then it's going to be all reals except for the values that make that equal 0, okay? So we need to factor this one. Luckily, we have plenty of practice with factoring. We know it's going to be x and x. And we have a positive 3 where the middle term is negative. As you guys can see, middle term is negative, but this is positive, so this can be minus, minus. Okay, and then the factors of 3 are 3 and 1. Okay, so x cannot equal 1 or 3. So it's all reals, okay, which I designate with that little terminology there, except x cannot equal 1 or 3. Look at h of x here. The only restriction is the denominator. It can't be 0 in the denominator. So we notice that it's 3. There's nothing for x to change there. So this is just simply all real numbers. Okay. P of x. The denominator, we have x squared plus 4. We cannot have that equal to 0. So we need to solve for x. We subtract 4, We get x squared equals negative 4. And as you can see here, there are no real numbers where this is the case. You're going to have imaginary numbers, but there's no real numbers where that's going to be true. So this one also is all real numbers. Okay. Now we're going to talk about canceling. So when we have terms in the top and bottom that are the same, we can cancel and simplify the expression. Okay. So here in the letter A, we see that we have a polynomial on the top as indicated by its factors, and in the bottom, and we see that x plus 2 and x plus 2 can be canceled because they're in the same. Now, they can only be separated by multiplication for us to cancel, okay? Addition or subtraction, we got to be a little bit more careful of, okay? And that leads us perfectly and segues perfectly into example B. So we can't just cancel the 6's because we see them in the top and bottom because it's not separated by multiplication in the top and bottom. So the first thing we need to do is factor the top and factor the bottom. Okay, so we're going to have A in the top. Okay, we need to think of the factors of negative 6 that will add up to give us a negative 2. So the signs are going to be opposites, and then negative needs to win. So the negative needs to be bigger. So that's negative 3, positive 2. Okay. Now let's look at the bottom. We're going to have A and A again, A. We think factors of 6. Positive 6, that gives us a positive 5. This one's just positive 3 and positive 2 plus 3. Now we're going to look for any common factors in the top and bottom. So here we see A plus 2 separated by multiplication. So our final answer is going to be A minus 3 over A plus 3. Okay, I forgot to mention over here, our final answer is egg plus 5 over x minus 3. Okay, this is where you really need to understand your factoring and be good at factoring in order to simplify these expressions. Okay, over here we're going to simplify top and bottom first, so we can factor out, we see this difference of squares, y plus 2 times y minus 2. This one's a binomial, but it's not difference of squares. We can factor out a 2, and we're left with y plus 2 in the bottom. We have common factors, boom, boom, y minus 2 over 2. Okay. Next one, we have difference of cubes. We recognize that this is a cube, this is a cube, so we're going to take the cube root of both those and put it into our cube root formula. So we have x minus 3, because it's difference of cubes, x squared, plus 3x, plus 3 squared, which is 9. Okay, if you don't remember how to do that, you're going to have to review the difference of cubes section. Okay. Now we see where they have x minus 3 here, and there's an implied parentheses here, so we can cancel that. So we have x minus 3, cancel. We are left with the expression x squared plus 3x plus 9, and that's our final simplified form. Now, these next two are special cases. Okay, so we recognize here that we have m minus 3 and then 3 minus m. They're essentially opposites, okay? So think of it this way. It looks like there's nothing to factor, but really what we can do is we can factor out a -1 in either the top or bottom. I'm just going to do the bottom, okay? And if we factor out a -1, what happens? The signs change. So a 3 inside the parentheses will become -3, because -3 times -1 will give us a positive 3. Then we have -1 times what will give us -m. Well, that's a positive m. Okay. If we rearrange this, we get m minus 3 over -1 times a quantity, m minus 3. So really what we did is factoring out a -1, we'll turn it to the opposite, and then it actually becomes the same value in the top and bottom. So we can cancel, and we are left with -1. Okay. If you want, if that was too fast for you, we have 1, because it gets canceled, over -1, which in turn is -1. Okay. Example F, we have r squared minus 15. We should recognize that that's difference of squares, so we have r plus 4 times r minus 4. Okay. In the bottom, we have 4 minus r. Now you're probably thinking, okay, this is disappointing because we can't cancel in the top and bottom. You actually can though, okay, but you need to do more factoring. If you recognize that these are opposites, then you can factor out a -1 in either and change it to match each other, okay? So what I'm going to do is I'm going to factor out a -1 in the bottom, okay? Let me show you what that looks like. So we have r plus 4 in the top, r minus 4 in the top, over -1, okay? Now if I factor out a -1, what happens? Let me erase this just so it's less confusing. -4 times what gives me -r? Well, a positive r. -1 times what gives me a positive 4? Minus 4. Okay? So now this is factored correctly. It's the same value. It just looks different. So we can cancel our r minus 4. So we are left with r plus 4 over -1. Okay? And divided by -1 is the same thing as just multiplying by -1. So we get -r minus 4. And that's our final answer. Okay, that would be okay answer, but really the most simplified form is -r minus 4. Okay, I'm going to stop here, and we are going to move on to multiplying rational expressions in a second.